All right, so if you watched the video I posted about the unit circle, the one from Desmos, hopefully you were able to learn a little bit about the unit circle. And I know I was talking about reference angles in it, but I'm going to go over in a little more detail what those are. So reference angles, I have three things I want you to remember about them. The first thing is that they are acute, so they're always less than 90 degrees. They're always going to be positive angles, and they are always formed with the x-axis. So, and again, the unit circle, those have special reference angles that you're going to use, but you can find a reference angle from any angle drawn in the coordinate plane. Now, if it's in quadrant 1, those are all going to be the reference angles because those are all less than 90 degrees. It's 2, 3, and 4 that you need to worry about. So notice for 4 here, if your angle goes past that 90 degrees and into quadrant 2, it'll be the angle formed when you go down to the x-axis, okay? Quadrant 3, again, you're over here, and then it's going to be the angle that's formed going up to the x-axis, so the little angle here. And then quadrant 4, again, you're going to go up to the x-axis and figure out that angle. So they're telling you the different ways you can find them, depending on if it's in degrees or radians. It doesn't matter necessarily if you use these, just that you're finding the correct angle, okay? All right, so let's go over a couple examples here. So we're going to find the reference angle theta for 5 pi over 3 and negative 130, okay? All right, so let's start with our first one here, 5 pi over 3. So if you have trouble understanding where this is kind of in the coordinate plane, that's fine. You can always take it and convert it to degrees if that makes you a little bit more comfortable with working with it. So use that conversion here. Cross out your radians, 3 into 180, 60 times. So it's going to give you 300 degrees. Okay, so it might help you just kind of visualize it as you're getting comfortable using these radian measures, drawing them. Let's look at 300. So we know, again, if we're in standard position, here is our initial side. We're going to go all the way around. So we know this is 270. How much further do you need to go? About 30 degrees. So I'm just going to sketch that in there. Okay, so there is your 300 degree angle. And then you're going to ask yourself, well, how much further up would I need to go to get to the x-axis? We know the whole circle is 360, so take away that 300, you'd need to go 60 degrees more. So that's going to be your reference angle. Now, our answer starts in radians, our problem starts in radians, so our answer should also be put into radians, okay? So 60 degrees is pi over 3 in terms of the radian. And you can do that conversion if you need to. To do that, you'll start to memorize some of these because that is a reference angle used on the unit circle. So 60 is a common one, okay? All right, and then let's try the last one here. So negative 130 degrees. So this one we are going to go clockwise because it's negative. We draw in our initial side. And here's negative 90, using those quadrants to kind of help you guide where you're gonna go. And then we wanna go 40 more to get to the negative 130. So just under half. Again, it's a sketch. You don't even have to draw them, but I think it just helps to have that visual there. Then you're going to ask yourself, how much further would you go to get to the x-axis? Well, you know the semicircle that's formed here is 180 to get to it, right? So you'd need to go 50 degrees more because you already went 130, even though it's negative, I know. But your angle here will always be a positive, okay? You don't need to do any conversions or anything, so it's already there. There's your theta is 50 degrees. And so that's how you can find any reference angle given another angle to draw. And then just on the bottom, I did give you some notes here. When you are doing those 6 trigonometric functions, making sure you're getting the correct sign for those. Okay, so as you're looking at them around the circle, just thinking about which values you're looking at.